Welcome back, everybody, to 1.7 Part 2. We talked about the midpoint formula. That was a lot of fun, but now we're going to be talking about the distance formula. Now, this is how I was taught. I was taught you get your little formula, you plug in your points, you'll label it, and you're done, okay? I think it's more important to understand why do we use the distance formula, where does it come from? Because honestly, when I'm thinking about this distance formula, a lot of times I don't even use it. I use what I like to call the Pythagorean Theorem. Now let me explain. The whole point of the distance formula is that if we have a non-horizontal or non-vertical line on the coordinate plane, we can find the distance of it. For example, A to B, we can find the distance, okay, using the distance formula, okay? Well, the distance formula, it is derived from something else though, okay? Normally, if we have horizontal distances, okay, like this, it's easy to count. We can just count 1, 2, 3, 4, 5, whatever it is, okay, for horizontal distances because it's right along the axis. Same thing with vertical distance. We can count 1, 2, 3, 4, whatever it is, okay, but we can't really do that diagonally. You can't use like the little counting method because there's no diagonal coordinate plane, no diagonal axes that we can just count along. So how do we do that? How do we find the distance between two diagonal points? Well, as you can see here, any diagonal point is always composed of a horizontal and vertical component. So here we have our horizontal component, and that's the x. Okay, this is our horizontal component. And then we have the y, which is our vertical component. And you can always get to any diagonal spot with these two things. Okay, so what we do is we connect the two, the horizontal and diagonal component, and you're going to create a what? A triangle. See that? See that wonderful triangle? We create a triangle when we connect the horizontal and vertical, okay? Now, the triangle has an important property, the right triangle has an important property called the Pythagorean Theorem. And I'm going to try to write it out, Pythagorean Theorem. Okay? You don't have to write this down if you don't want to. You'd be cool if you did, but you don't have to. All the cool kids are doing it. Okay, the Pythagorean Theorem states this. Usually they have a side length. So let's just say we have this as side A. Okay, I'm going to move this y over. You might ask why, and I would say yes. Okay, and then I have this as B, and then we have this as C. This is typically how you see Pythagorean Theorem represented. Okay, now Pythagorean Theorem states the following. Oops. A squared, let me get my black out, plus equals, okay, there we go. A squared plus B squared equals C squared, okay? Now, what are we looking for here? If we're trying to translate this and we made our coordinate plane like we did here, okay, see how we have a right triangle, we have a horizontal distance represented by the red, the x, we have a vertical distance, the blue, okay? And those could be side lengths of our triangle. And we're trying to find this distance here, this distance, okay? So what would that distance be on our triangle? Well, that's C. So we need to get C by itself. How do we do that? Well, in order to get C by itself, we have to take the square root of both sides. Once we do that, we get C equals, and we can ignore the negative square root, we just need the positive, equals the square root of A squared plus B squared. Okay, now A squared and A is just the length of a side, B is just the length of a side, but what if you're just given coordinates? These coordinates don't represent length, they just represent spots on the coordinate plane, okay? So let's take, for example, what if this x coordinate was 2, and then this one over here, in line with this B, okay, so if we drop this B right down, this spot, this x coordinate was 6. What would be the distance between those 2 points? Well, if it goes from 2 to 6, then clearly that is a distance of 4. Okay? Going from 2 to 6 is a distance of 4. So what did we do there? What mathematics with 6 and 2 did we get to get 4? Well, anytime we're talking about distance and we're talking about the change between one place to another, we're using subtraction. Okay? Change and subtraction go hand in hand. So we're talking about subtraction. What did we do here? Well, instead of just writing A, we don't know that, we're talking about the coordinate plane. Instead of A, what we did is we took x2 and we subtracted x1. We took one of the coordinates and we subtracted it. Okay, so that's represented with A. A is the same thing as subtracting the two x coordinates. And it doesn't really matter which order you do. Most people have x2 minus x1, but really you can do x1 minus x2 as long as you do the same thing with the vertical component with the y's. Okay, just want to throw that out there in case you're wondering. But just stick with this and you'll be fine. All right, now, same thing with B. So if we're looking for the change in the coordinates here, we're looking for this distance, this vertical distance here, because we need to know what that side length is. We can do y2 minus 1. We can find the change in the y's to see what that distance is. And we can see our vertical distance. Okay, so over here, instead of writing B, I'm going to write y2 minus y1 squared. Now, according to this formula, that's my A. I need to square it according to the Pythagorean Theorem. y2 minus y1, that's my B. I square it according to the Pythagorean Theorem, and I take the square root of that, and that will tell me my distance, C. So this is the distance formula, okay? So the distance formula is x2 minus x1, and then y2 plus the quantity y2 minus y2 minus y1, both of those quantities squared, and take the square root of all of that. That's where it comes from. So if you just want to use the Pythagorean Theorem, you know those distances really quickly. You can count over on your little coordinate plane, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, and count up. Honestly, that way might be quicker. If you don't have a coordinate plane drawn, then this distance formula might be better. Okay, but I'm just saying, don't just automatically think that you always have to use the distance formula and don't understand what it is, so you just plug it in and this is mindless and you hate math. Okay, that's why people hate math, is because they don't understand it. If you have a visual understanding of it, then at least you can make some progress, learn, and grow. Okay, that's the whole point. People just want to see themselves get better. Am I right? All right, sorry. I'm off my soapbox and we're on example 3. Find the distance between negative 5, 4, and negative 11, negative 4. So in this case, we don't have a coordinate plane drawn. We could either draw one, which takes a little time, or we can just label it and use it with, what do you call it? What did I say? Distance formula. Okay, so we label this. Now, does it matter which one you call x1, y1, x2, y2? No, as long as you're consistent and you don't mix up like x1 with y2 and then y1 with x2 or something like that, okay? All right, so we have distance is going to be equal to distance, as they say in France. Distance equals square root okay, and then we're going to take my x2, negative 11, minus a negative 5. Make sure you include the negative sign and put little parentheses in there. I'm glad that we got a lot of negatives in here. Now we're going to do negative 4 minus 4. If you want, you can put parentheses around the 4, but it doesn't matter because you're going to distribute the negative to the whatever. You get the point. Okay, so this is going to be equal to our distance. So now we say, okay, let's simplify inside the parentheses. I have a negative 11 minus a negative 5. That's the same thing as negative 11 plus 5 squared. Okay, and then over here I have negative 4 minus 4. That gives me negative 8, and I square that. Okay, and then I'm taking the square root of this whole thing. It's important to stay organized and rewrite this. I know you're like, oh my gosh, there's so much writing involved. I'm sorry, but if you don't write, a lot of times that's when mistakes were made. The number one way I see students make mistakes is when they don't write everything out line by line and they try to do it in their head. And they're like, oh man, I just made a stupid mistake. I knew how to do this. I'm like, well, I'm sorry. Part of the battle is staying organized. It's great that you know it, but you have to stay organized too. Okay. All right, so then we have plus 64. Negative 8 squared is 64. Negative 6 squared gives us a positive 36. So we had 36 plus 64. Man, I chose so many colors. Why? Okay, square root of all that. Okay, that's the same thing as the square root of 100. Guess what that is? It's either plus or minus 10. We don't care about minuses because we're talking about distances. So the distance is 10, and there's no unit, so we're going to say 10 units. There we go. There's the distance formula. Hope you guys enjoyed it. Thank you so much for watching, and I'll see you next time on West Explains Best. Take care.